Good afternoon, everyone. Have you enjoyed the conference so far? Yes? Well, this is what it's doing too. It's good I'm the last one in the, today, so I can take extra time at the end. No, I'm just kidding. I won't take more than 20 minutes extra. Okay. So this is my second time at SATURN. My first one was last year, and I learned so much last year that I was thinking, like, I want to contribute to this community. So this is my attempt at doing that. I want to give back a little bit back to the community of the learnings that we went through at my organization. So a little bit of background of where I work. I work at Nulogy Corporation. We're based in Toronto, Canada. Actually, the only 3 Canadians in this conference are from Nulogy. So 15 years ago, 4 engineer grads came together to build a system with the goal of like decreasing the waste in the global supply chain. Many of the items that you use daily were probably touched by one of our systems. We serve big brands like Kellogg, P&G, DHL, L'Oreal, and other ones. Since all our founders are engineers, we take our software craft really seriously. We are a learning organization, use modern agile methodologies, TDD, and pair programming. And also, we're growing really fast. For example, last year, our product development team grew by 40%, which it posed some challenges to the organization, especially one of them is in the infrastructure, how we manage infrastructure. So before I get into the talk, I want to define key terms I'm going to be using during my talk, because you know our industry has terms that are very overloaded. So the first one is infrastructure. Whenever I say infrastructure in this talk, I mean everything for deploying your application stack. So it's not just application configuration, it's also everything that is around it, like databases, network configuration, security configuration, logging, monitoring, deployments. All that is part of your infrastructure to run your application stack. And then infrastructure as code is having all those components in code. So you describe it as code that is executable by a computer, and then that will give you that infrastructure that you're describing. And the last one is environment. In this talk, when I say environment, I mean deployment environment. So for example, you have an application stack that you could deploy to different kind of environments with different reliability and availability requirements. For example, your production environment, probably everyone has that. And then you have testing environment, staging environment, and any other environment that you want to create. Okay, now let's think for a moment. Let's assume like we're like building a new app. It will be the next big thing, and we're ready to release the first version. A naive and traditional way of deploying this new environment would be to go through your provider website. Who is familiar with this page? That's the AWS page where you pick the service that you want to use. In our case, we're deploying a web app, so we're gonna use the EC2 computing environment. And then the next page, we pick we launch an instance, and then we set up a few configurations on the website, and then we launch the instance, we SSH to it, upload the code, run the app, and then you have your application running in production, ready to be used. Now, assume like this app becomes very successful, and like it evolved, right? Our architecture became more complicated, and we ended up like adding a few different databases. We have message brokers. We added a few microservices. And everything around it, like to support all the monitoring and the logging. And it became quite complicated now. Like, how many people have worked in this kind of environment where it's more than just a web server and a database, right? So it's very common. So imagine now that your development team probably grew a lot to support this. And if any developer wants to deploy a new environment, like provision a new environment from scratch, and you keep using the traditional way of deploying infrastructure, you're probably going to be blocked by some people that know how to do that. So this block, maybe you're blocked by a team normally the operation teams. And this is an issue because now teams are being blocked. The developer team is blocked by the operation team or whoever knows how to deploy this environment. A concrete example that we had in our company is when we want to upgrade the stack, let's say the Ruby version, we want to deploy a new environment so we can start testing and see what regressions we can have. And we're often blocked by operations team that will have to prioritize that task and do it when they have time. And it's kind of like, it takes some time. So there is no autonomous team, and we prefer to have an autonomous team. So we want infrastructure that is self-service, that any developer can just go ahead and deploy your environment. So what about documentation? Ideally, we want up-to-date and complete documentation. And why is that important? If tomorrow there is in the news that, okay, there is this particular vulnerability on a version of Linux, that ideally you go to the documentation, you can see right away what you're using, and then you could figure out if you need to upgrade or not. So ideally we want a better, complete and up-to-date documentation. What about deploys? Like if you are following manual steps, it's going to be a lot of waiting around. Like the dev or the operation team will be waiting for commands to finish before they can run the next one. So it's a lot of waste. Also, you could get to human errors where the configuration drift a bit between one environment and the other one. And also imagine your production environment has been running for 5 years. How confident are you that the environment that you deployed today has the same configuration or as close as you want them to be, right? We want environment parity, which improve safety. You always know the state that your environment is and your infrastructure is. So we want speed and safety for working with our infrastructure. Let's assume that you have someone let's say on the operation team that wants to change a firewall rule. So he SSH into some of the server, change some configuration, some firewall configuration, and then go home. And then he goes on vacation next day. And customers start calling saying, we are dropping connection, something is going on. How hard would it be for the people that remain to debug the issue, to figure out what's the problem, why the change was made, and how to safely roll it back? So that is a lot of time wasted, and it's risky. So ideally, we want to find a way of having every infrastructure change in version control. And if you have version control, then you could apply different kind of good practices like code reviews, automated tests, security checks, static analysis, all these amazing practices that have proved to increase the quality of your code. So one validation. And another one, let's say in this fictional company that we want to create a new microservice, or we want to start a new app to get into a new market. We're going to have to reinvent the wheel to put that application or microservice in a production-ready environment. We'll have to repeat a lot of configuration that we do manually, and that's a lot of waste. And we had that problem in our organization where it's so hard to get to microservices because you don't have this code, this infrastructure as code that you could reuse on all your application. So we want reusability. And finally, how much happiness do you think the devs will get from SSH into every single server to make a change and then log back? And it's stressful because they are live, and it's also a lot of waste, things that are repetitive and tedious. So we want to optimize for happiness when you work in with your infrastructure. So we want all these benefits, and guess how can you get all these benefits? Well, you could use infrastructure as code. And it's kind of clear why that's the case, because you have code, you could clone, any developer can clone that code, run it, and then they get a new infrastructure, a new environment for your application. You have documentation. The code is the documentation that is going to be complete and up to speed. You have automation, so it's going to be fast, very fast to get new environments going on. And you also control how much parity you want between your environment, how close you want them to be. And then again, if you have code, you should use version control for your code, obviously. And then you add all these like amazing validation techniques on your pipeline that will help you deliver high quality infrastructure. And then you got reusability and happiness, because computers are doing what they do best. They do the repetitive labor, and then you left your developers to do what is more important for the business. So if I want to map it to quality attributes, one that is very clear is maintainability. I believe like a maintainability of your infrastructure will improve a lot if you use infrastructure as code, and you could like see from all these benefits that help with maintainability of your infrastructure. You get better security by running all these amazing checks on your changes. You get testability as well. You could automate the testing before go to production. And then you get reusability. To me, these are the main quality attributes that infrastructure as code helps and optimize for. And like most of the time, yeah, you want most of like these 4 quality attributes. Maybe sometimes you want 3 of these, but most of the time, infrastructure as code will be better than if you don't use it. And like, if you guys are going to go with one message, only one message from this talk, I want this message to be that code is powerful, and that what I mean by that is like if you find yourself going through your provider's website to make some configurations, or you find yourself SSHing into a machine, I want you to stop there, remember this talk maybe and this phrase, and like think if there is a better way of doing that change that you're making, and if you could automate it in code, because it will be a lot helpful in the future. So that's my main point of the talk. Now, there are many tools to get this, and like as long as you follow the principle, the tool is less important, but you also want tooling that helps you get infrastructure as code. And you might ask, okay, so implementing infrastructure as code, there is an initial investment cost for doing that. You need to write code, you need to have your developer learn new technique, new tools, and that's expensive. So for my second part of the talk, I want to show you how easy it is to actually implement infrastructure as code. It's way lower, the cost, the investment cost is way lower than you might think. And this is changing everything nowadays. So many tools, the reason we picked Terraform, it is a lot simpler to get started and to maintain, because you don't need an agent or a master. You don't have to install any agent on your production infrastructure. The language is very declarative, which helps a lot with documentation. The infrastructure, by default, it tries to make it immutable. That helps a lot with like the environment parity that we prefer. And you're kind of going to see that as I do the live coding. It's open source, work with any cloud provider, or almost all the cloud providers. And the only downside is like the newer of all these tools, but it's getting a lot of traction from the community. The community is growing a lot. Okay, so what is Terraform? Terraform is just a binary that you download, you put in your computer. You write your code in TF files, Terraform files. Then you run that binary, and what it does, it parses the code that you wrote there, and it figures out the set of API call that needs to make to the providers, to the cloud providers, to give you the infrastructure that you just described. It supports a lot of providers, and this list might be outdated. But in here you can see it supports AWS, Google Cloud, DigitalOcean, the Microsoft Cloud, OpenStack, Kubernetes. It supports a huge list of providers. So even if you don't want to run it on the cloud and you're running on-premise, you could actually install, for example, OpenStack in your hardware and like still use Terraform to deploy your infrastructure. Here's how it looks like. As you can see, it's very declarative. And here you could say like, okay, this seems to be using AWS as the provider. US is one region, and then it's provisioning this instance, which is just a computer instance with this image ID and the size of the instance. Again, very easy to read. So you run your Terraform, it will read that file, and then it figures out all the API calls that it needs to make to your provider. And then it will give you, it will convert what you described on the file so that you could have the same infrastructure on the cloud. So let's go to live coding, so you could get a sense of how it works and how really easy it is to use it. All right. Can you see that? So I'm in this directory, and the only thing in this directory is a file. I'm going to open that file. And as you can see, it's empty. I'm starting from scratch. This is actually from scratch. So I'm going to deploy a web server. First thing that you need to do is to specify your provider. So use AWS is what I'm going to be using. And I want to deploy to this region. So as you can see, Terraform, you define blocks. And there are different block types. The first one that I'm showing you is provider. And then you have an argument, which is what provider you want to use. And then you have a list of attributes that you could specify inside the block. Region is the only required attribute for this provider, but you could specify other ones. So the other type of block is resource, which you could specify what resource you want to use or provision. So in this case, is an AWS instance. The second argument in here is an ID. It's a name, any name you want. I'm just going to call it my instance. And then you specify the AMI. So I already figured out what is the Ubuntu AMI that I could use, so I have it on my clipboard. So that's the ID for an Ubuntu image. And then the type. For this example, I'm going to be using C5 large. And that's it. We have something that's ready to provision. This is our first infrastructure. So now you go to the terminal in the same directory where your file is, and then you run Terraform apply. So what apply will do, it will see what you have. So that was quite quick, but what it did is it checked what you already have on the cloud, all the infrastructure you already have there. It checks what you have in your code, and it will compare it and figure out how to convert whatever you have on the cloud. So as you can see, this is the first time I'm creating this. So it's saying, OK, I'm going to create a new instance. And you see some of the attributes that I specified. The other ones will be computed. And then a nice summary at the end. So this is part of the Terraform cycle to check before you apply the changes. So I want to apply those changes. And if I logging into the console, so you can see, so forget the terminal. This is an old one that's still showing here, but this is a new one that is just creating. So that's my instance starting up, and it's already running. And Terraform will wait until it's up and running and give you a nice summary again of what happened. Now, if you look at the console, we're missing a name. It's nice to, for organization, to have a name for every instance that you deploy. It's good to know what all the instances are doing. So Terraform code is quite good and up to date. And if you, for example, if you use search for this using Google, probably the first hit that you will see is the Terraform documentation. And here you can see how to use this type of resource. Give you a nice example how to use it. And the argument reference. So you see it has a lot of argument. You have a lot of power to decide how you want to configure it. But we're looking for this. The example tells right there how to tag an instance. So let's go back to the code. By the way, is the code readable? I know sometimes from the back it's hard to read it. It's good? Nice. All right. So we use an inner block that's tagged, and then the one that we're going to use is name. So let's just tag it that way so we know what is this for. Now we go back to the console. If I want to apply the changes, what should I run now? Who knows? What was the same command? Apply. So again, you run apply after making your change in the code. it will compare what you have out there with what you have in the code, and it like and there you go. It will tell you, okay, you want to update, so you know it can update in place. It will just tag that instance with what you specify. That seems to be right. So it will go and do that. That one is quite quick because it's just tagging. If I refresh here, there is my my tag, the tag that I just specified there. Okay, so well, that sounds good, but I mean, what is an instance running if it's not doing anything at all? So let's actually, well, before I do that, let's say we want to change the region of our infrastructure. And let's say we want to make it easy to change regions. Who was yesterday on the James Lewis talk about the evolution architecture? Who was here? Do you remember at one point he mentioned like they could change the region by changing like 1 or 2 lines of code? So we want to kind of do the same. Why not? So who can tell me what lines needs to change in order to change the region in here? Which one? Okay, so line 3. What else? Would that be it? Huh?
Maybe 8 size.
No. So I'll give you a tip. In Amazon, the AMI IDs are scoped by region. So if I want to run the same Ubuntu AMI in another region in Europe, for example, I need to figure out what the ID is on that region for Ubuntu. So right now, as the code is, I have to change this line as well, line 7. I mean, we could do better than that, right? Just change one line. That would be. So I'm going to show you another block type that you could use, and it's very convenient. It's called data. So data, I want to get the auto-completion because it's not. OK, so data, what data does is it tells Terraform to query for things that are already on your cloud provider. So for example, if you, let's say you are migrating your infrastructure to infrastructure as code, this is very useful because you could migrate one resource at a time. And then you could use data to like fetch what is already provisioned, and then you could link it with your new code here. For our case, we know Amazon has a list of AMIs, public AMIs already on the provider. So we want to fetch that image. So I call it Ubuntu. And then inside the data, you supply filters. So what are the filters that you want to use? So I want to get, what I'm saying here is I want Terraform to ask my provider for an AMI with that name, which is an Ubuntu. It's just the name that Ubuntu or Canonical uses for publishing images. And for safety, since names are not unique, and you want to make sure you get the right image, I also specify the owner. So you say, okay, make sure this is the owner, and give me that AMI. Figure out where it is. And then now I could actually use the result of that data block in my instance here. And for that, you use what is called Terraform interpolation. It's just using that syntax there. And then you specify which one is the one they want to use here. So here's where like the name that you use is important because I call this Ubuntu. So I want to make sure I get Ubuntu. And this is the attribute that I want to use from that data that is returned there. Okay, so now it's very easy to change region, right? Like I only change one line, and Terraform will figure out what the AMI is for that region. Now, if I run Terraform apply right now, what do you think it will happen? Who can tell me what will happen if I run Terraform apply?
Nothing.
Why?
Because it's already set up.
Correct. So here's where you see the parallels with application, like writing application code. It's like this is like a refactoring. We made our code a bit better, but the behavior didn't change. So if I go back to a terminal and run Terraform apply, you should try to get this feedback loop very short, like keep running apply as you make changes. Terraform will figure out this is the same AMI ID that you're running. I mean the same image ID that you're running, so nothing to do. and that's what you get there. Okay, now let's go to run an actual server. So for running our server, we're gonna use an attribute that is called user data. So I just have it on my clipboard. I don't want to write all the code again, but essentially this is a very simple server. So user data, what Amazon will do with user data, it will run whatever code you put there when the machine starts. So here we have some bash code, and we're putting this text, hello Saturn 2018, into an index HTML file, and then I'm opening an HTTP server to serve that file over port 8080, right? And the other thing that you need to do is to open that port. So Amazon by default closes all your port to the instance, makes a good security default. So let's actually change that a bit. So for that, I'm gonna use a security group. I'm gonna call it web security group. And then here you specify the rules for the incoming traffic. For example, you could say, okay, I want to accept any incoming traffic to port 8080 using TCP. I want to route that to 8080 inside my instance. And another one that we should specify is like what IP addresses are allowed to talk to this instance. So I use the CIDR syntax, which is a way of specifying ranges of IP. And this range means anyone in the internet, any IP address can talk to my instance. All right, so we define this firewall. So this is like a firewall rule, right? Like it's a security group, is what they call it. And now I need to tell this AWS instance resource to use that security group that we defined. So for doing that, what do we use? We use Terraform interpolation. So you say, okay, the security group for this instance is gonna come from this one that I defined down there. So as you can see, the ordering of your block, it doesn't really matter. I mean, this is declarative. And Terraform, what it does, and I found like it's quite cool, it figures out the trio dependencies, and then it will parallelize as much as it can to like give you that infrastructure. All right, so we're almost ready. I want to actually, to make it simpler for us, I want to get the IP address of this instance that we're creating. So Terraform provides another block type called output. So I'm gonna name it public URL. And then here you refer whatever you want to show in the output. So we're gonna use, gonna make sure I refer to that instance I created there. I call my instance, terrible name, but that's what we have. And then the attribute I want to show is the public IP. And for convenience, I'm also gonna put the port here. So output, when you run Terraform apply, and I'm gonna show you that right now. So what do you think will happen with this command now? It's gonna hide it a bit here. Terraform apply. So I added a user data that only execute when the instance starts. So what do you think Terraform will do now? Any guess?
What page can I give you an IP to that, or an import to that?
What will it do with the old one? The one that is already running? Add to it? Almost close, but no. It will actually destroy the old one and create a replacement, as you can see here in the plan. So this is called the plan, which it shows you whenever before it actually make the API calls to a provider. And if you look at the attributes, it will tell you here that this change of user data, it will force a new resource. And it also tells you like the security group that will create. So it will add new things, it will destroy an old one. So this is where the immutable infrastructure is coming from. Like you make a change and Terraform sometimes would just like destroy the old one and create a new one, which is a good way of like deploying, because that way you make sure the configuration is in a well-known state. And it's safe to destroy that instance whenever you want, because you could like create a new one and it should still work.
How about people that were dependent on it, it's gone now?
The people that are, yeah, so this is not perfect yet. So I mentioned like it will be 0 downtime deploys. This is not 0 downtime deploys because the instance is going away before the new one starts, and it's also using a different IP address. Like what it comes after this, just to put a load balancer on top of it, so you could swap the instance below, and you could tell Terraform to create the instance before it destroys it, and you could also configure the load balancer to drain connections when before destroying the whole instance. So I won't have time to show you how to set up that, but that will be homework for you guys. So here's the outputs now. Like there's a new section here that prints the output, and you can see the IP is there. And there's another way of getting the output, which is just running Terraform output. Give you that. So let's say you run Terraform, you provision the infrastructure last week. You go back to this directory, you run Terraform output, and it will give you the output again. And then you could also specify the particular output that you want to get, and will give you the value there. And this is quite convenient because now you have a bash script running something else. It could get the output of like this public URL, and you could embed it in other programs. For example, I could just do curd. So what this will do, it will execute Terraform output, and the value, the output of that command, I'm going to curl it. So I'm going to hit that endpoint and see if it works. So let's see. Hopefully my web server is up there. Oh, there you go. So it returned. So we have a web server running already. It's returning that text that I put in there. Okay, so I mean, we want to do deployments. You want to like have like the same code all the time returning. So let's customize that message so it's easier to like change it. So a way of doing that is by using another block type. It's called variable. So variable is like input that you want to add, put into your Terraform. So for example, I could call it, give it a name message. And you could also specify default if that variable is not specified. So like let's not break compatibility with like other people using our code, although no one is using it, but who knows. I'm gonna just get this as the default. And now I could refer to that variable from anywhere on my Terraform code. And for that I use Terraform interpolation. So this var message. So I can actually like swap out that message very easily by just changing the value that I pass to Terraform. Now, who could tell me if I run Terraform apply right now, what will happen? Nothing, because I'm using the same default as before. So there is many ways of specifying variables, like the value of your variables to Terraform. You could put all the values in one file, let's say a JSON file, and tell Terraform use this file. You could pass it as arguments to your Terraform command, or you could use environment variables as well. So for this example, I'm going to use environment variables. So the how you do that is you prefix it with tfvar, and then you put the name of your variable in there. So let's say see you at SATURN 2019. Terraform apply. Okay, so again, it's the same cycle. Terraform will compare what you have out there in the cloud with what you specify. It will realize that the user data changed, and the only way to execute that user data is by restarting the computer. So it will force a new resource. We're making deployments with immutable infrastructure now. So yeah, let's say that's okay. Let's make that change. And you guys don't believe me, you could see here. It's terminating, so it's shutting down the old instance. That's the one that was live. And then after that, it will create a new one. Any questions so far? Quick question as this is finishing. Well, I guess it's done. So again, it print the new IP, and now I could curl it. Now, since this is not zero downtime deployment, it's close to it. It's only like maybe a minute of downtime. The server is still like running that code that we put there, so at this point, I haven't finished running it, but it's gonna get to a point where the new message will show up. And now we have our server back running the new code that we just deploy. So that's kind of the workflow. And again, if we want to make it really zero downtime, you add the load balancer, like, and the documentation is really good, and there is plenty of examples out there how to do it, examples in the internet. All right, so there's one last command I want to show. That's called Terraform destroy, and guess what that does? What that will do. So it keeps track, Terraform is keeping track of all your resources that you have been creating. This will just clean up all the stuff that you had. So if you're experimenting, this is good so you don't keep paying that AWS bill, which is nasty. And C5 large are like very expensive. So as you can see, it will tell me that it will destroy these 2 resources. And yeah, and once it's done, then nothing will be, so it will be back as where you were when you started. So that's the Terraform destroy. So let's go back to the presentation. All right, so again, this is like what you were seeing all the time that I run Terraform applies, like this cycle of like, of course, there's a plan stage here that I didn't show, where it shows you like, hey, this is what I'm gonna do, confirm, but this is more or less this. It's very simple. If you want to learn more about Terraform, this is a good book to start, and it's very easy to read, small, and you get all information from there. The source code that I use today is in this GitHub repo. Use it for your homework of like adding zero downtimes. And again, who can tell me the main message from my talk, the one that I want you to get home for sure? Yes, code is powerful. Do it, because you get all the benefits that I talk about, and like you get to do evolution architecture as well. Well, you need a few more practice on top of that, but this is the start. I hope you enjoyed my talk. Thank you. And there's some time for questions.